Okay, watching this video is going to get you ready for the last test of the grading period, the test over rational functions, unit 6.3. So the first thing we're going to review is what a function like this represents. So when you see a function like this, we know it represents a 1 over x. So I know that it's got two asymptotes, and I can tell that there's a horizontal one right here, and it's passing through y equals 3. I can also tell that I've got a vertical asymptote right here, and it's passing through x equals -1. Because I know my two asymptotes, I can write my equation in terms of y equals. So I'm going to have y equals 1 over, because I went left 1, I'm going to write x plus 1 in the bottom. Some of us like to put it in parentheses, that's fine. And because I shifted up 3, I put a plus 3. On your test, they're going to ask for you to write these equations in terms of f of x, knowing that f of x equals 1 over x. To do this, when you write down the f, it's representing 1 over x. Whatever I put in parentheses up here will also go in parentheses for my function. The plus 3 is not in parentheses, so it'll go on the outside. They want to know what are the horizontal and vertical asymptotes. Your horizontal asymptote is the equation y equals 3. Your vertical asymptote is the equation x equals -1. The domain is what's going on in your graph from left to right. So this domain is going from -infinity all the way to -1, but not including -1, union -1 to positive infinity. So this means everything but -1. When they ask you for the range, my range is everything but 3. So we're going to write it in a very similar manner. -3, -infinity to 3, parentheses, union 3 to positive infinity. And this means everything but 3. On 5 through 8, they're giving me this equation right here, and they're asking me to put this in graphing form. And this is how it's going to be on the test, where they're going to ask you to do one thing, and then they're going to ask you several questions about it. So it's really important that you solve this graphing form correctly. So when we're putting it in graphing form, the x plus 1 is going to go outside the house. The x minus 3 will go inside the house. How many times will 1x go into 1x? It goes one time. Then I multiply everything over here by 1, and I get x plus 1. And then we're going to subtract. And you have to remember to subtract each term. X take away x is going to go away, and x minus a 1 is going to give me a -4. So when they ask me for the graphing form, we're going to have y equals, your remainder becomes your numerator, so -4 over x plus 1. What you have at the top for your answer becomes what you add or subtract onto the end. So my graphing form is y equals -4 over x plus 1 plus 1. They want me to write this in terms of f of x, so just like we did up here above, same kind of thing. If it's in the parentheses, then we're going to keep it in the parentheses. If it's not in parentheses, then we don't. So this right here could be written in parentheses. So I'm going to go write a -4 outside. Then I'm going to write f parentheses x plus 1 plus 1. There we go. They want to know the horizontal or oblique asymptote. This is a horizontal asymptote of y equals 1. It's got a vertical asymptote of x equals -1. Remember, your horizontal asymptote is out here. That's shifting me up and down. Whatever's in here is shifting me left and right, and that's my vertical asymptotes. On 9 through 11, they give me a summary of some long and short run behavior, and they ask me what picture it could be. When I get to a problem like this on the test, I like to make my own sketch first. So this is my x, and this is my y. And they tell me the long run behavior. And remember, your long run behavior, it's what's happening left and right. So I know as x goes to -infinity, I'm going to be below -1. So I'm going to go sketch in -1. Y equals -1. And I'm going to be below -1 on this side. And I know as x approaches positive infinity, so as my x's go this way, I'm going to be above -1. Okay, so just doing that part, I can already get rid of some of these. This goes down to negative, has a horizontal asymptote of -3. This has a horizontal asymptote of -3. This has a horizontal asymptote of +3. This has a horizontal asymptote of -1. So I already know my answer is going to be D. I'm going to go ahead and talk about the short run behavior, just in case on the test you've got more than one possible answer once you get the horizontal done. So the short run behavior tells me my vertical asymptote. And it tells me that I'm going to have one at 3 on the x. So here's my x equals 3 line. And it says when I'm going to the right of 3, I'm going to go off to positive infinity. So to the right of 3, I'm going to go off to positive infinity, which means I'm going to go up. And it says right here when I'm to the left of 3, when I'm over here on this side of 3, I'm going to go to negative infinity, which means I'm going to go down. So then it just validates the fact that I picked D and that was the correct answer. 9, 10, and 11 are going to be questions about this same graph. So that was 9. On 10, it says what is the equation for the graph. So looking at the graph that we just did a second ago, they want to know what is the equation of that. So if I were to write the equation, I know it's a 1 over x. It went right 3 and down 1. So y equals, if I went right 3, I'm going to have x minus 3. And if I went down 1, I'm going to have a minus 1. Then they want me to write that equation in terms of f of x. We've done this several times now. So if it's in the parentheses, I write it in the parentheses. If it's not in the parentheses, then I don't. And you're done. Okay. On 12, 13, 14, and 15, this whole problem has to do with this one thing right here. And it says use the equation below to answer the questions regarding its long-run behavior. So if you'll notice, when they ask you about long-run behavior, you try to reduce first. Well, if I reduce, it doesn't change to 1 over x or 1 over x squared. So this is another division problem. And these were a little bit harder for some of y'all. All right, so how many times will 1x go into x squared? 1x will go into x squared x times. So then I have to multiply. X times x is x squared. X times 1 is 1x. And then we're going to subtract. X squared minus x squared cancels. 5x minus x will be a 4x. Well, I can still keep dividing. How many times will x go into 4x? It'll go 4 times. Now I have to multiply. 4 times x is 4x. 4 times 1 is 4. And then we're going to subtract. When we subtract, the 4x minus 4x is going to go away. The negative 6 minus 4 is going to equal a negative 10. Okay, so I'm going to come over here and write my equation. Remember, your remainder goes on top. What you divided by is your denominator. And what's out up here is going to end up being your horizontal or oblique asymptote. In this case, it's going to be oblique. Okay, so that says plus x plus 4. I just wrote that a little messy. Okay, so if I wanted to know what the long-range behavior equation was, it'd be y equals negative 10. This would reduce to over x. So that's what it's going to look like, a negative 1 over x with an oblique asymptote at x plus 4. So the equation of the asymptote is y equals x plus 4. It's oblique. If I were to graph this, I want to know what would the end behavior look like. So if I were to go graph the oblique asymptote of y equals x plus 4, it would be a line that looks something like this. That would be x plus 4. It's a negative on the top. So normally, if it's positive, I'm above on the right and below on the left. Because it's negative, I'm going to be below on the right and above on the left. So as x approaches infinity on the right, we're going to be below the asymptote. And as x approaches negative infinity, as it moves to the left, we're going to be above. Okay, let's go look at 16 and 17. On 16 through 19, it says consider the long-run behavior of this function. Well, this is actually a lot nicer. On this particular problem, I can reduce by looking at my leading coefficients. And it reduces, if I write it down as x over x squared, to 1 over x. So the long run behavior of this function is going to look like a 1 over x. 1 over x's have horizontal asymptotes at y equals 0. And the behavior statement for a 1 over x is as x approaches infinity, we're above on the right and below on the left. So I want to be above on the right and below on the left. And that's what statement B says. Okay, on 20 through 22, it says to consider the short run behavior of the function. So when you're doing the short run behavior, we need to see what it behaves like. We're going to do 18 over x squared. Because if I FOIL that, I get x squared. And the short run behavior is going to tell me what my asymptotes are. So I look at this first number, and that's why I never, ever, ever want to divide by 0. So what would make this first one 0? X would equal 3, so that's one of my asymptotes. What would make x plus 2 0? Well, if x were negative 2. So those are my two asymptotes. They asked me to find my y-intercept. When they ask you to do this, you have to let x equal 0 and solve for y. So I'm going to come up here to this top equation. I'm going to write y equals 18 over 0 minus 3 times 0 plus 2. Everywhere there is an x, I plugged in a 0. Well, 0 minus 3 is negative 3. 0 plus 2 is 2. So we have 18 over negative 3 times 2 is negative 6. And 18 divided by negative 6 is negative 3. So my y-intercept is at 0, negative 3. On 23 through 28, it says use the equation below to answer the questions. What is the graphing form of the equation? Well, if they give you one that can be factored, you're going to start by factoring, and I can factor down here on the bottom. So on the top I have a negative 3. On the bottom I'm going to pull out my GCF. I corrected this in class. That should be a plus 27. I get x squared plus 6x plus 9. This can be factored further. So we have y equals negative 3 over 3. What factors of 9 add up to 6? X plus 3 and x plus 3. So x plus 3 squared. These can be reduced. So if I reduce those, I get negative 1 over x plus 3 squared. So that's my graphing form. Y equals negative 1 over x plus 3 squared. So the x plus 3 squared, I usually call that the volcano problem in class. It's not moving up or down at all, it's staying right here at the 0, at y equals 0. It is going to move left 3, at x equals negative 3, because we do the opposite. Because there's a negative on top, instead of it opening up, it's going to open down. So when we were graphing these, I said, okay, go to the middle where the two asymptotes intersect at the cross, and I'm going to go right 1, and instead of going up 1, I'm going to go down 1. It's going to look something like this. I'm going to go do the same thing on the left side of the asymptote. I'm going to go left 1 and down 1. Your x squareds will always do the exact same thing from both directions. They'll always come in together. They want to know what is the horizontal asymptote. It's y equals 0. The vertical asymptote is x equals negative 3. For the y-intercept, we're going to do it just like we did in the problem above. I'm going to go plug in 0 everywhere I have an x. So if I plug in 0, I'm going to have negative 3 over 3 times 0 squared is 0. 18 times 0 is 0. And 0 plus 0 plus 27 is 27. And negative 3 over 27 is negative 1 over 9. So my y-intercept is negative 1 over 9. My x-intercept does not exist. This function will never, ever, ever touch the x-axis because of that horizontal asymptote. On 29 and 30, they gave me some information about my long and short run behavior, and they wanted me to sketch a graph and write a possible equation. Okay, so let's see what we got so far. So I'm going to start by sketching a graph. And they tell me it's going to look like a negative 1 over x for my long run. So I know if it's going to look like a negative 4 over x, that my horizontal asymptote is going to be right here. And I know that because it's a negative, I'm going to be up on the left and down on the right, the opposite of what I would normally do because it's a negative. So that's how the first part of the graph is going to look. Then they tell me my short run behavior. I'm going to have a vertical asymptote at negative 2. X equals negative 2. And I'm going to have another one at positive 2. Okay. And they tell me at both of these, we're going to go in the negatives of what I would, of the graph. So when I'm at positive 2, my positive would be up and then down. But I'm going to do the negative. So I'm going to go down here and up over here. I'm going to do the opposite of what I normally do. So far it looks kind of like this. Okay, now I'm going to come over here to this asymptote, and it's also a negative. So normally I would go up on the right, down on the left. I'm going to do the opposite. I'm going to go up on the left and down on the right. So this piece is going to look like this. So I have to connect these two, and this is the one that kind of looks like the S. Then they want you to pick an equation or write a possible equation. I know that on the bottom I have to have this x plus 2 and this x minus 2. And because I have that on the bottom, I know that's an x squared. But I want it to reduce to a negative 4 over x. So I want a negative 4x on top because an x and an x squared will reduce to negative 4 over x. Okay, your test is on Monday, so make sure you watch this video again on Sunday to prepare for your test. Good luck!